Let's work this problem related to pump efficiency to apply the principles that we learned on how to calculate pump efficiency. In this problem, we are told that a farmer uses a nearby creek to irrigate a small plot where he grows rice. He must pump the water from the creek up to the rice paddy, a height difference of 5 feet. Assuming 110 kilograms of water is pumped into the rice paddy every minute at a velocity of 1.3 meters per second, what is the power that would have to be delivered to the pump, assuming an overall pump piping system efficiency of 15%? So immediately what I do when I work this problem is I identify my goal. What am I trying to find? I know that I'm trying to find the power in watts that has to be delivered to the pump in order to make this scenario happen. Now, next, what I would do is I would start to identify the given information in the problem. The first number that I'm given in the problem as I read through it word by word is that there's a height difference of 5 feet, and that's how much the water must be pumped from the creek to the rice paddy. So I know that that's going to be my pump head. I have a pump head of 5 feet. Now at this point I see 5 feet and I know that feet is not what I'm going to be working with. I want to change it into meters, but I'm going to keep writing down my known information before I start changing any units. The next number that I come across when I'm reading the problem is that 110 kilograms of water is pumped into the rice paddy. That's my mass. I know that kilograms is a term of mass, and so I can put my mass is equal to 110 kilograms. And I also see that it's pumped every minute. That's my time. So I'm going to write down my time value. Time is equal to 1 minute. I continue along reading and I see that there is a velocity that is given to me of 1.3 meters per second. So I'll also write down my velocity term of 1.3 meters per second. I read that I need to find power, which I've already identified, and I also see the final bit of information, and that is a system efficiency of 15%, which I will also write down as my given information. Whenever I'm given the term efficiency or I'm asked to find efficiency, I immediately think I need to use that efficiency equation. And so what I do at this point is I like to write down that efficiency equation. When I write it down, I can reference it to see what I have, what I don't have, and what I'm trying to find. Remember, your efficiency equation is weight times height plus 1/2 mass times velocity squared, which is your potential energy plus your kinetic energy, divided by your electrical energy input, which is voltage times current times time, times 100%. I know from when I learned about electrical power that the equation for power is V times I. So I know that that term V times I is what I'm trying to find for this problem. So now let's look at the other terms to see what we have and what we need. Looking at weight, remember that weight is equal to mass times gravity. Mass is given to us in the problem, which is 110 kilograms. Gravity is a known quantity. So I know I have my weight. Height was given to me as 5 feet. I know I have my height. And then mass again was given to me in the problem. Velocity was also given to me in the problem. It's 1.3 meters per second. V times I is what I'm trying to find. The time was given to me as 1 minute. So I have time. And then the other term that I have in this equation is efficiency, which was also given to me. So I have all the components that I need in order to solve for voltage times current, which is power. However, before I do that, I need to make sure all my units are in the right form. Whenever I'm working with these pump efficiency problems, I always want to work with metric units. And so I see that my height is 5 feet. So that's the first thing that I want to change. I want to go in here and change 5 feet to meters. There's 12 inches in 1 foot, and I know that there is 2.54 centimeters in 1 inch, and I know that there's 100 centimeters in 1 meter. So I'll do the calculation to find feet, to find pump head in meters, which is 1.524 meters. My mass is in kilograms, which is the units that I want it to be in. My time is in minutes, which is not the units I want it to be in. I want it to be in seconds. That's a quick and easy calculation because I know that 1 minute is 60 seconds. My velocity is in meters per second, and my efficiency is a unitless quantity. It's 15, it's just a percentage. So now that my units are all in the form that I would like them to be in, I can start plugging in the values that I know. I know my efficiency is 15%. My weight is mass times gravity. So my mass is 110 kilograms times gravity, which is 9.81 meters per second squared. And I calculated my height to be 1.524 meters. Now I'm going to add that to kinetic energy, which is 1/2 mass, which is 110 kilograms, times velocity, 1.3 meters per second, that term squared, divided by my voltage times current, which is what I'm looking for, times time, which is 60 seconds. And all of that is multiplied by 100%. Now I can rearrange this and solve for voltage times current and rewrite my equation. And now I have it in a form where I have the power is equal to all the terms that I know. I can calculate that out and I get power to be 193.06 watts.